Well, hello and welcome to Mesa Shafe's classroom. Today we're going to continue talking about thermochemistry, and in particular today we're going to be looking at Hess's law and running through some problems using Hess's law. So let's get started. Okay, so Hess's law states that the change in the enthalpy of stepwise process is the sum of the enthalpy changes of the steps. Now that might sound kind of weird, but basically it just means that the overall total is going to just be the sum of the parts. That's all it is. But let's talk about the parts just for a little bit and some of the things that we are going to be doing. So let's look at first, if I have an equation, I'm just going to grab one here real quick, which is CH2CO and gas plus 2O2 gas. I think this is one of the first problems that you do. And it yields 2CO2 gas plus H2O gas. And one of the things is that we know the heat of the reaction here is going to be a negative 981.1 kilojoules. Now, a couple of things that we're going to do, and so I'm just going to do a couple of things to this problem, just showing you as an example. Think of this, if you've been in math class at all, you've done systems of equations, okay? Systems of equations, where maybe you have x plus y equals 10, and then like 2x minus y, I'm making up something here, is 8. Let's just say. And one is you can just eliminate the y's. But if you have a problem that is something like x plus 2y equals 10 and 2x minus y equals 8, then in that case you're going to need to multiply one of your equations by something else. So maybe I want to, actually in this case I would probably multiply my bottom equation so that when I multiplied, I had 4x minus 2y equals 16, and then those canceled. So we're going to do the same thing with our chemical equations, because we're going to be doing the exact same thing here. We're going to be simplifying by getting them to be the same value so that we can cancel them out. So let me show you again how we're going to do this. Let me get rid of this. Okay. So if I needed, in fact, to have 4, maybe I needed 4 oxygens instead of 2, then I would multiply my entire equation by 2. And when I multiply that entire equation by 2, I'm going to leave off my gases for now. Just like our system, I would go through and be sure I multiply everything by the 2. But here's the kicker. Not only do you multiply the equation, you must also then multiply your energy by 2 also. Okay? I'm not going to multiply that out, but also your energy must be multiplied. Okay? Now, if you'll remember, when you do systems of equations, sometimes you need to subtract or change the sign. Okay? So the same thing here, when we're going to change the sign of something, or in this case, when we need it on the other side. Okay? What we do is we can just flip this. I'm going to go back to my original, and I'm going to take my products. They are now on my reactant side, and my reactants are going to go to my product side. Okay. When I flip these, because my products became my reactants with my products, what I have to do to my heat of reaction is change the sign. So now it will become a positive instead of a negative. Okay, so those are 2 important factors as you start doing Hess's law that you need to remember. One, just like systems of equations, you can multiply the entire equation and the heat of the reaction by a number. Or if you need it on the other side of the equation, you're going to do the opposite. So that's when you make the products, the reactants, reactants, products. But don't forget, you change the sign of your heat of reaction. Okay, so let's just get started and put this to work. Okay, so here is going to be our problem that we're going to be working on. So we want to calculate the enthalpy change for the reaction in which methane and oxygen combine to form ketone, which is the CH2CO and water. So this is the final product that we're looking for. So they've told us what our answer needs to be. We just need to figure out how to take these two equations and get there. Okay, so let's just analyze this just for a little bit. So the first thing on our answer equation is we need a CH4, and we need it, on the left side. And we need two of them. We need two oxygens over here, which is pretty good. We already have two oxygens. We need the ketene, which is this piece, on this side. So it's got to move to the other side. And our water, we need three of them. I've got two here, or one there and two there, so that looks good to get the three waters. So you just got to figure out a strategy of where you're going to start. I think what I want to do is, let's move this one over to the other side. And if you remember, when I want to move it, then that is changing the reactants to the products and products to the reaction. So it is a flipping of these two equations. So I'm just going to come down here below and I'm going to flip these two equations, or this equation, and see if you can follow what I'm doing. So I'm taking this piece, which is the products, they're becoming the reactants. And now I'm moving the reactants to the product side. Okay, so I just flip-flop those. And remember, the rule was when you flip-flop those, you change the sign of the heat of the reaction. Okay, so there's my first step. That's the first one I've used. Okay, the next one. So it looks like I've got this moved over. So there's the first part. It looks like I also need two of these. So let's get two of those. So this is where I'm going to do a multiplication. So I'm going to multiply the entire equation by 2. So I get 2 CH4 gas plus 4 oxygen gas yields 2 carbon dioxide gas plus 4 water gas. Again, since I multiplied this entire equation by 2, I also must multiply my heat of reaction by 2. And so that's 802.3. Probably do that in my head, but I better, it's late, do it on a calculator. So, whoops, 802.3 times 2. 1,604.6 kilojoules. Okay, so let's look at what I have now. So here's my two equations I now have. So I just flip-flopped these, made this negative, or changed the sign of it, and I multiplied this entire equation by 2. And again, just like in math classes, be sure you multiply everything, because if you miss, you're going to mess up something. Now, just like in math class, when I add these two equations now together, I can see what I have. And so I'm going to go ahead and just put the whole thing together, and then we'll just see what we have. So I have 2 CH4, and then we'll talk about how we could possibly shorten things down, plus the 4 oxygen gas. Hopefully I have room here. And then I have 2 carbon dioxide. You see where I'm getting that gas? I probably should have started with this one first, plus H2O gas. Okay, so basically what I have currently done, probably done that, these two added together give me and that's going to yield. So now I'm going to put these two together. So I have CH2. I'll go ahead and anyway, gas plus 2O2 plus 2CO2 gas plus 4H2O. I'm running out of gas. Okay, now just like an equation, we can start simplifying, because one thing is I see 4 oxygens here and 2 there, so it's kind of like doing a minus 2 oxygens, see, just like what we did in math class. Okay, so those are gone. I have 2 carbon dioxide and 2 carbon dioxides, again the same thing. Cancels, those are going to cancel there. And let's go back up here. We'll say we want our waters on the this side also. So I'm going to, so according to where you wanted your waters is what I'm saying, because I want them on the product side. So I'm going to move this one over. Okay, so that's gone, and then I've got 4 minus 1. So now let's rewrite the final results here. I have 2 CH4 gas. Okay, I have 4 minus 2, so that's going to give me 2 oxygen gas. Those canceled, those canceled. I've got CH2CO, which was the ketene, which we were looking for, plus, and 4 waters minus 1 water gives me 3 waters. And now compare that equation to what I was wanting. And if you'll notice, you have that equation, okay? Now, let's go back. Do you need to write this all equation out? I would say that's up to you. If that helped you to do it this way, by all means, I want you to do that. But for some of you, you could just come up here to this piece maybe, and or the whole thing, and start looking at it and say, okay, well, I've got 2 CO2s here and 2 here. As long as you have one on the product side and one on the reactant side, you can cancel those again. I've got a water here and 4 here, so this becomes 3 waters. Okay, I've got 2 oxygens and 4, so that becomes 2. Now I'm going to tell you, I would only suggest you do this if you can really keep yourself organized in your thought process. If you cannot, I really suggest that you write it all the way out. Okay, so once you have your equation finished up, your equation matches and so forth, you're not done yet. Okay, you do have one more step left to go, because the question you're wanting is what the enthalpy change is going to be for this to all take place. And that's where we're going to come over here, because to do the first step, the multiplication or the flipping of products and reactants, we ended up with a delta H of 981.1 kilojoules. When we multiplied everything by 2, we ended up with 1,600, and I dropped a negative off of there. I just now realized that, because we just multiplied by 2. We did not flip it, so it's a negative 1604. So the final answer, we still need to take and add these two together. So this equation then would have a delta H of the sum of those two. So take your 981.1 and subtract 1604.6, and we get a negative 623.5 kilojoules. So that is your overall change in enthalpy, heat of reaction, for this reaction to occur. So don't forget to go back in. Again, don't do like I did and drop a negative off, because we did not flip, okay, products and reactants, so that should still be negative. I'll leave that up for you to decide which way you want to do it. I'm going to do another video where I'm going to do a couple more of these. If you feel comfortable and you're ready to take off, then by all means you can continue on without the next video.